Good morning, everyone. Today we are going to be talking about intermolecular forces, the three types, and how to identify them. First, before we get into the different kinds of intermolecular forces, it's important to know what intermolecular forces are versus what intramolecular forces are. So, intermolecular forces are actually the forces between molecules. So, within a substance, there are intermolecular forces between all the little molecules or atoms in the substance. These forces draw the molecules and compounds together, and they're much weaker than intramolecular forces. Also, if you break or change the intermolecular forces, it's going to result in a physical change, such as a phase change from a solid to a liquid or a liquid to a gas. Next, on the other side of things, we have the intramolecular forces, which we learned about earlier are the bonds between the atoms themselves, which form the compound. So these are like covalent bonds that are dependent on the sharing or donating of valence electrons. These bonds and these forces are much stronger, and breaking them requires a chemical change because it actually changes the compounds itself and not just the substance. So now that we've learned what intermolecular forces are, let's learn about the three different types: London dispersion, dipole-dipole, and hydrogen bonding. First, London dispersion forces are created when there is a temporary uneven distribution of electrons within the atoms. This means that more electrons are pulled to one side of the atom, which creates a negative end where more electrons are concentrated, and a positive side where less electrons are. Then this same thing happens to other atoms or other molecules in the substance, and the temporary positive and negative ends are attracted to each other, creating some attraction between the molecules. London dispersion forces exist between all molecules, whether they're polar or nonpolar. Also, London dispersion forces are the weakest of all the intermolecular forces, which is why they're able to exist even in nonpolar molecules. Also, while they are the weakest normally, if a molecule has a lot of electrons, the London dispersion forces will become stronger because when there are more electrons, they have more attraction because there's a more overall charge to attract them with the positive and the negative. The next type of force that we're going to be learning about is dipole-dipole forces. Dipole-dipole forces occur in polar molecules, which is because, if you remember, polar molecules happen when there's a difference in electronegativity of the two atoms in a molecule, which causes one molecule to pull electrons toward itself while the other molecule has its electrons pulled away from it. So, like if you look at this example, chlorine is more electronegative than hydrogen, so it pulls electrons toward itself, and hydrogen has them pulled away, creating a negative end and a positive end. These are not temporary negatives and positives like in London dispersion, but they're more permanent because it's a polar molecule, which makes dipole-dipole stronger than London dispersion forces. So then, once you have a positive and a negative end, the positive end, such as hydrogen, where there are less electrons, is attracted to the negative end of another molecule where there are more electrons. Dipole-dipole forces are usually stronger than London dispersion forces. I say that they're usually stronger because if London dispersion forces are in a molecule with a lot of electrons, like we discussed earlier, they can actually become really strong and may be more powerful than the dipole-dipole forces of a smaller molecule. Also, while every molecule and atoms have London dispersion forces, only polar molecules have dipole-dipole forces. Last but not least is hydrogen bonding forces. Hydrogen bonding is a very specific type of force, and it can actually be seen as an extreme dipole-dipole because it occurs when hydrogen is bonded to one of these extremely electronegative elements, either fluorine, oxygen, or nitrogen. Because these elements are so electronegative, they pull the electron away from hydrogen, creating a very negative end and a very positive end, which have extreme attraction between molecules, with the positive hydrogen of one molecule bonding to the negative fluorine, oxygen, or nitrogen of another. These bonds are very strong and very hard to break. Some more about hydrogen bonding is that, as we mentioned earlier, they kind of operate similar to dipole-dipole forces with a positive and negative side, but they are much stronger. Also, if you're trying to think of a good example of hydrogen bonding, water, one of the most common substances, actually has hydrogen bonding because the hydrogen molecule is bonded with the oxygen. The hydrogen atom is bonded with the oxygen in a water molecule, which the oxygen pulls the electrons away from the hydrogen and creates a negative oxygen and positive hydrogen. Also, it's important to remember, because the word bonding can be confusing, that you need to look at the bonding between two different molecules. So this dashed line here, not the bond between the hydrogen and oxygen within the molecule. Okay. These forces can tell us a lot about how substances work, such as their boiling point, viscosity, and their surface tension. And before we go, I'm going to give you a quick example and then you can check your answers. So here's a practice problem. Just pause the video, try your best, and then what you're going to do is tell which forces are in each of these molecules, and then we'll check our answers. Okay, so for the first one, you should have gotten only London dispersion forces because it's a nonpolar molecule. There's no hydrogen. Then the second one, you can see that hydrogen is bonded with nitrogen, which creates hydrogen bonding because it's one of those three elements, hydrogen, and with either nitrogen, oxygen, or fluorine. Also, it has London dispersion because every molecule has London dispersion, and it is polar, so it has dipole-dipole as well. So this one is very strong forces. Last but not least is bromine chloride. Only has London dispersion and dipole-dipole because there's no hydrogen bonding, but it is a polar molecule, and every molecule has London dispersion. Thank you so much for watching, and we'll see you next video. Bye!